Alright students, welcome to the final lesson of our trigonometry unit. I hope you've made your best effort to follow along with these lessons. I have made previous recordings of the previous lessons as well, so please make sure you watch those on my YouTube channel if you need to watch them again and recap on what we've learned so far. Now in the previous lesson, we looked into how we use inverse trig ratios, so that's in one of my videos. Like I said, if you want to watch that, please go ahead and do it after this session, obviously. But remember that we use these three trig ratios to find unknown angles. Okay, so inverse trig ratios are for finding angles, whereas normal trig ratios are for finding unknown lengths. In this session, we're going to look at applying inverse trig and also normal trig in order to find unknown lengths and unknown angles with application questions. If you are writing notes, please refer to this page in your booklets where it says 4D applications in 2D. All right, let's make a start. Before we actually get into the nitty-gritty of this lesson, while I scroll to it, just remember some of the previous things we learned when it came to finding unknown angles, just operations, these parts here. Okay, how we have these unknown to figure out, how do we then isolate and figure out what the x is in these questions. So it is on the top. Let me just rub this out for us so we can actually see what's happening here. I might get rid of that so I can work it out for you guys. But if your unknown is on the top, remember that the idea behind these questions is we need to figure out what that unknown is. And the terms that I've used was isolating that unknown. So in order to isolate that unknown number there, we need to then move that 2. Now that is a divided by 2 on this side of the equal sign. So if I move it over here, it becomes multiplied by 2. So if I put that in my calculator, it's going to be 2 times the sine of 45. And that will give me whatever x is. If you get that, just press SD. There's your answer. So that means the answer of x is 1.41. Okay. Now if we try the other ones, we've got these sorts of questions where the unknown or x is on the bottom. Remember that it's the same principle. You're trying to isolate that x, make it by itself. So in order to make this by itself, with this sort of equation, we need to swap the sine and whatever angle it is with the x. So if we swap them around, this sine will go down here, whereas this x will now go where the sine used to be. So if I rewrite the equation, it should look like this. X is equal to 2 divided by the sine of 60. Oops, sorry. Sine of 60. Let me fix that so it looks better for you guys. Looks like it's disappearing left, right, and center. But that would then equal, on my calculator, use your fraction button if you're confused. So fraction button 2 divided by the sine of 60, which equals 2.3. We can round it to 2 decimals, so 2.31. Okay, that would be the value of x. So you need to remember how to use those skills in order to, yeah. I did jump a little bit ahead, but just so you're aware, these are our LI and SCs, or learning intention and success criteria. So today, of elevation and depression. So those are a couple of new terms that we haven't really come across yet in class. Actually, we have, but we didn't really go in depth with it. And then again, like I mentioned, it's all about calculating unknown side lengths and angles. Okay, with regards to elevation and depression. And last lesson, we went through in our bound reference being able to draw diagrams. So make sure you listen back or look back at that lesson, try and remember the basic things we need to be able to do in order to draw an appropriate diagram. Most of the diagrams we draw, again, will be based on triangles, as this is trigonometry. So you don't need to have a pretty diagram, just make sure you've got the appropriate diagram for the question that you're doing. And we might be using a bit of Pythag as well. So just keep that in mind and don't forget everything that we learned about in the previous sessions. Okay, so let's look into angles of elevation and depression. So when we're talking about angles of elevation, okay, you're looking at it's about a certain way or a certain direction in which you are referring to an object. Okay, and when we talk about the direction, let's imagine that you're this person, okay, and their eyes, you could say, are the starting point. Now from there, what you can see is from their eyesight, there's a line called the horizontal line. That horizontal line is a reference point, okay, where you begin, because as you start there, if you look at anything above that horizontal line, it's referred to as an angle of elevation. Or you can see that an angle created there is called an angle of elevation. It's above that horizontal line. Okay, so whenever you're focusing on an object above your horizontal, it's called you inadvertently create an angle of depression. Now the same is of the opposite. So if you have your horizontal line and you're looking at something below that horizontal, it creates an angle of depression. Okay, so just keep that in mind when it comes to angles of elevation and depression. Your horizontal line is your reference point. If you're looking at anything above the line, it creates an angle of elevation. If you're looking at anything below the horizontal, it creates an angle of depression. Okay, and you can also use these as your definitions for that. So look back on them if you need to. So here are more explanations of it. So angles of elevation and depression are terms that we use to describe when we're focusing. Like I mentioned previously, it's about looking at an object that is above or below that horizontal line, and it does create an angle between that horizontal line and whatever it is that you're looking at. So you can see, if you go back to this example, actually let's go to this example. We'll use this example. If you go to this example, if you are the boat down above you, you can see that for this boat, this is the horizontal line here, and they're looking up, okay, at an object, which in this case is the lighthouse. So that means this creates, as you can see, an angle there, which is elevated, or an elevation angle, which is above, again, that horizontal line. It's above, and the angle that we've created here is an angle of elevation. However, if you go look at the other way, okay, if you were a lighthouse, okay, and you're looking down at an object, okay, so here is your horizontal line. So if you're up there, there's a horizontal, and you're looking down at an object which is down here, it creates here an angle of depression, which is in there. Okay, so this is the angle of depression, whatever it might be. Let's try and look at another example here. Okay, say you were the cat and the bird. If you were here, okay, and your horizontal line is right there, and you're looking up at that bird, it creates an angle of elevation there. Okay, so yeah, the cat's looking at the bird, looking really hungry, probably wants to eat it. Okay, it creates an angle of elevation between the horizontal and the line of sight, or wherever the cat's looking at. If you're the bird, however, over here, okay, and there's your horizontal, so where your eyesight is as the bird. If you're looking down at the cat, okay, you can see that it creates an angle of depression. Okay, from the line of sight of the bird and the horizontal, so between those two lines, creates an angle, and that's the angle of depression right there. Okay, hope that's making sense to you all. And if you are writing notes, great, please use them for when we do questions. More examples again, and a couple of things to note when it comes to angles of elevation and depression. So if you're at the top of the cliff, okay, for example here, right, looking at an object below your horizontal, it creates, as you can see here, an angle of depression. Now the interesting thing here is because if you actually create when you have these sorts of questions, you can create a rectangle within your sort of subjects, and what it creates is, what you often find is some of the angles actually equal one another. So if you're at this top of the cliff, okay, right here, you're looking, and here's your horizontal, and you're looking down at something, it creates an angle of depression. And in this case, the angle of depression is 34 degrees. Now, the interesting thing is if you are the object down here and you're looking up at whatever the top of the cliff is, there's your horizontal. It creates an angle of elevation that's actually the same. Okay, an angle of elevation that's exactly the same as the angle of depression. Okay, so I hope that's it is kind of making sense to you all. But here's another thing to keep in mind. What you'll see and what you notice is this also, if you look at the corners, it creates a 90-degree angle. So if that's the case, if this angle, for example, so at the top, if that corner creates a 90-degree angle and this angle here is 34, that means that this angle here is 56 degrees. And what that also means, because remember that these angles are the same, that this angle here must also be 56 degrees. Okay, because down here you've got a 90-degree angle as well. So they're kind of like mirror alternatives of one another. Okay, so keep that in mind. When it comes to angles, okay, you'll find that if the angle of depression here is 34 degrees, it will be equal to the angle of elevation down here from this point of view of whatever the object is. And similarly, okay, you can make a rectangle there, and remember that in the corners of the rectangles they equal to 90 degrees. So if this angle here is 34, that would mean that the rest of this should be 56, which is actually the same as this angle as well. Okay, so all in all, in the same context as it says down here, angles of elevation and depression are actually equal. All right, let's put some of this to practice and actually make sense of what it is we're talking about. So in your exercises or in your notes, sorry, it's going to go back to the start, but please follow along and try and answer this question with me as you watch this video. So, at a certain time of the day, a light post that is 5 meters tall casts a shadow of 2.2 meters. So let's stop there for now. You've got a light post that's 5 meters tall. Okay, so that corresponds with that length. And casts a shadow, okay, that is 2.2 meters. So the shadow of the light post is right there, which is 2.2 meters. What is the angle of elevation of the sun at that time? Okay, angle of elevation of the sun. So which angle, okay, let me actually highlight that. What is the angle of elevation of the sun at that time? So what we're looking for is some sort of angle of elevation. So which angle are we looking at in this? Well, I can already see a triangle there. Okay, what you might want to do is you've got some space there. You could potentially redraw this because there's going to be questions, okay, where it's just words and you need to be able to draw the diagram. So practice redrawing your questions. I would recommend that you practice redrawing the questions so you can actually know what to do. So you know that down here, you've got a shadow that's 2.2 meters and the height of the lamppost is 5 meters. Now, if you're looking for an angle of elevation, okay, where would that be? Well, if the sun, let's imagine that the sun is over here, okay, and we're looking for its angle of elevation. Let me fix that up. We're looking for its angle of elevation. Which angle am I looking at? Well, you've got two options. You're either looking for this angle or this angle. Now keep in mind it's asking us for the angle of elevation. So if you're up here, okay, and there's your horizontal, and you're looking down at something, okay, which is this point here, remember what angle does that create? Well, it creates an angle of depression. Okay. Now technically, remember what I said, angles of elevation and depression are equal, but in this regard, just to not make it confusing, okay, well, technically this is a depression angle. So you could look for that and actually get the right answer, but let's try to stick to an angle of elevation of the sun. So let's not look for that angle. Instead, however, let's go down here, okay, because if we're down here and we're focusing on the sun up there, okay, so if there's my horizontal here, okay, and you're focusing on an object above the horizontal, okay, which in this case is the sun, that creates an angle of elevation, which is there. So that means the angle I'm looking for is right there, that angle, which is an angle of elevation of the sun. So from there, you've seen these triangles before. What do we need to do? Well, we need to first label the triangle. Okay, label that triangle. So if there's my reference angle right there, the side opposite of that is called the opposite. I might go OPP, so we know that's the opposite, not the number 0. And the side next to the angle is the adjacent. Okay, because in this question we're looking for an angle, we have to use inverse trig ratios. So think back to what ratio has adjacent and opposite. It would be the tan ratio. So that means it's the angle is equal to tan inverse opposite over adjacent. Okay, if you forgot that, make sure you look at your notes. If you haven't already got this in your bound reference, or these inverse ratios and trig ratios, make sure you put them in your bound reference, please. So let's rewrite this now. So the angle is equal to tan inverse, my opposite according to this is 5, and my adjacent down there is 2.2. Okay, so put that in a calculator. The angle should be, so tan inverse, if you forgot, press shift first and then select tan, and then use your fraction button, 5 over 2.2. Close the bracket, and the angle should be 66.25. Alright, so the angle of elevation there is 66.25. Now, if you remember back to the start of this question, or when I was sort of drawing the diagram, remember when we did this as well, and I mentioned that this technically is angle of depression, which is correct. This angle is actually the same as that angle as well. So you could have done that, but just be precise with the question. It is asking for the angle of elevation, not the depression. But if you found this depression angle and said, oh, it was the same as that, you should get the mark for it because they're technically the same. All right, let's go to another question. Diagram is already drawn, but just watch here how we draw the diagram so you know what you need to do. Wire connecting the top of the radio tower to a receiver on the ground. So what we're trying to do is we're trying to connect this top to a receiver down here. Okay, they want to create some sort of a wire. Climbing to the top of the tower, he observes that the receiver on the ground and calculates an angle of depression of 38 degrees. So what that's saying is if the guy's up there, here's the horizontal line, okay, and he's looking down, okay, at the object, it creates an angle of depression of 38 degrees. If the base of the tower is 175 meters away from the top of the receiver, okay, so if this base is 175 meters away from the so the distance between the base of the tower and the receiver is 175 meters. Calculate the length of the wire needed to connect. So the length of the wire is this yellow line. Needed to connect the top of the radio tower to the receiver down here. Okay, so you can probably already see the diagram here partly, but I'll highlight for you all the triangle. So here's the triangle that we're looking at. Let's use another color. Here's the triangle that we're focusing on, right there. Okay, so I'm going to redraw it on the side here so you can actually see what we're working with. Oh, actually, before I do that, remember as well, another thing is this angle of 38 degrees, what's it the same as? Well, it should be the same as the angle down here. Okay, because the angle of elevation and depression, so if this is depression here from that point, elevation from here is exactly the same in terms of the angle. So let me redraw what we have here so it's a little bit clearer and we can work with it. Actually, I might move it all the way here. Okay, so let's redraw the angle of the triangle, and yeah, you guys hopefully can make more sense of it. So here's the tower. Okay, we don't know how tall it is, but that's okay. Here's the base of the tower to the receiver, and this is the wire we're looking for. So we're looking for this length of wire. This angle here is supposedly the same, so it's 38 degrees, as in the same as that depression angle there. And the distance from the base of the tower to the receiver is 175 meters. Okay, so for this question, we're looking for an unknown length. Remember, when it comes to trig questions, always start off by labeling your diagram or the size of your triangle. So if there's your reference angle right there, that's your opposite. Okay. Your longest side is always the hypotenuse, and the side next to it, which is this side, is the adjacent. So thinking back again to the trig ratios that we learned, remember normal trig ratios are used for finding unknown sides. So that's what we're going to use. Which normal trig ratio will have a hypotenuse and the adjacent? It would be the cos ratio. Okay, so cos of the angle is equal to adjacent over the hypotenuse. So let's use that ratio. All right, so cos of the angle, which in this case is 38 degrees. Oops. 38 degrees is equal to my adjacent, I can see here, is 175. So that's 175 over my hypotenuse, which in this case is the unknown and the thing that I'm looking for. All right, so now if you come across an equation like this, okay, remember back to what we learned when we were doing these questions. You're trying to isolate x, make it by itself. So for this type of equation, what you're going to be doing is swapping x with that cos 38. So x will go here, and that cos 38 will go below that 175. Sorry, that's not 17.5. All right, so let's rewrite it. So the equation should now look like this. X is equal to 175, sorry, I went back to 17.5, 175 divided by the cos of 38. Okay, so when we put that in the calculator, what this will give us is the length of x, which is the length of y that we need. Alright, so it's going to be 175 divided by the cos of 38 degrees, which equals 222.09. So the length of wire we need is 222.0. Actually, we'll just go 0. Yeah, 0.8, sorry. I said 0.9, didn't I? Okay, and that's the length of wire needed in order to connect the top of the receiver, the top of the antenna to the receiver. Alright, U10s, that's it for this tutorial. I'd like you now to go ahead and do the exercise questions for the 2D. These questions here, I'll just go to them for you. So do these for this session, and then you'll move on to another thing afterwards. Okay, so you'll be doing these questions here. Cool, have fun.